אנחנו עוברים עכשיו להרצאות על החלל החדש. ואם כבר חלל חדש, מה אם לוויין זעיר יכול לספר לנו סוד גדול על האוויר שאנחנו נושמים? אני מתכבדת להזמין את פרופסור קולין פרייס, ראש החוג החדש ללימודי סביבה וראש המכון לחדשנות תחבורתית, מדען אטמוספרי בעל שם עולמי, המתמחה בתחום האקלים ומזג האוויר. בנוסף, פרופסור פרייס חוקר את הקשר בין התפרצויות בשמש שלנו ותופעות אטמוספריות בכדור הארץ. הוא פרסם מעל 130 מאמרים מדעיים ומכהן כנציג ישראל בארגון הבינלאומי של גיאופיזיקה IUGG. בימים אלה מוביל יוזמה להקמת מרכז לננו לוויינים באוניברסיטת תל אביב. בבקשה.
So, for Shirley and John, I decided to speak in English. The translation is not very good, so I'll give the translator also a break in the back. I'm going to speak in English and hopefully everyone can understand my English. So, I'd like to start off by asking you a few questions. Do you know how much it costs to build a satellite? How many people we need to build a satellite? How long it takes to build a satellite? What the size of a satellite is? Well, today we're going through a phase, actually a revolution in space, in satellites, in studying the Earth from space, a revolution we call new space. And this revolution is changing the way we study space and look at the Earth from space. In the past, when we had to spend maybe $100 million or more to build a satellite, today we can do it with less than $500,000. If it took 10 to 20 years to build a single satellite, today we can do it in less than 2 years. And if once satellites looked like this, the size of a bus, today they look like they're the size of a shoebox. So what can we do with this new space? Well, we're here at the university, Tel Aviv University, and one of our main focuses is basic research, or research in general. Basic research is to better understand the physics, the chemistry, biology of our world, to expand our knowledge. But applied research is also important, to be practical, to find solutions for humanity, to monitor what's happening around the planet. But perhaps just as important as the research is education. At the university, we're educating the next generation of students, and space is an ideal tool to educate students on science, technology, engineering for the future. So I'll give you a few examples of basic research, applied research, and what we're doing on the educational side of things too. So let's talk about clouds. This is one of my favorite topics in research. Everyone looks at the clouds in the sky, but do you know that the clouds cover about 60% of the planet? And because of their white color, they actually reflect 20% of solar energy and actually have a cooling effect on the Earth. With no clouds in the sky, we would be about 20 degrees warmer on the planet. So clouds are really important. But now we've discovered that instead of 20% being reflected, because of all the air pollution in the atmosphere, the little particles, the dust particles, the smoke particles, diesel, the soot, is resulting in cloud drops becoming smaller with time. And when you have smaller droplets, the clouds actually become whiter. And when they're whiter, they reflect more sunlight, and they may actually be reflecting 30% and actually cooling the Earth, having an opposite effect to global warming. If we look at the oceans cover 70% of the planet, and here we can see an image from satellites of phytoplankton or chlorophyll, which tells us something about the biological activity in the ocean. This color here represents what we call phytoplankton. These are microscopic algae in the ocean. And they're the food for zooplankton, which is the food for the bigger fish and the larger fish, and eventually our food as well. And one of the questions we're asking today is if the oceans are getting warmer and also they're getting more acidic, how's that going to affect the phytoplankton and the whole chain of events, the food chain in the oceans? Ozone hole. I'm sure most of you have heard about the ozone layer and the ozone hole. The ozone layer is a layer of gas 20 to 30 kilometers above our heads, which protects us from the damaging ultraviolet radiation from the sun. And only because of satellites did we discover that a hole formed in the ozone layer, but it formed over the poles, over the North Pole and the South Pole where nobody lives. So without satellites, we wouldn't actually know about the hole in the ozone layer. And because of the use of satellites in space, we were able to go to the policymakers and to tell them there's a problem. And today we're trying to monitor the ozone layer to see its recovery after CFCs and freon gases were outruled by industry. If we have a look at applied science to better the humanity, if we look at this picture from space of air pollution over China, all this gray area is the air pollution. And I should point out that today nearly 10 million people die every year because of complications from air pollution. Satellites in space allow us to monitor the pollution from space, but also the pollution in the oceans. Oil spills in the oceans again, 70% of the area of the planet, nobody lives there. So in order to find out where the oil spill is, when it started, who's responsible, we can use space and satellites. Deforestation. Here are two pictures from the Amazon, on the left in 1975 compared with 2009. And the clear areas here show where we have deforestation, where the forests have been changed to agriculture, to pastures. And the rainforests around the planet are the lungs of the Earth. They take up the carbon dioxide and they release oxygen back into the atmosphere. By changing the rainforests, we're actually impacting the atmosphere and our lives as well. Closer to home, if we look at humanitarian disasters, the war in Syria, this is the refugee camp on the border of Jordan and Syria. And from space, we can map the refugee camps, the changes in the size of the refugee camps. And then this can be used for people working on the ground, the NGOs, to try to help the people on the ground, but not only from wars, also from natural disasters, earthquakes, tsunamis, flooding. Satellites in space can be used to map out these natural disasters and to help the people on the ground. And finally, we've heard about the city. Here you can see an image of Las Vegas from 1972 to 2012, the growth of the urban regions over time, which are monitored from satellites, so we can use satellites to actually plan what's happening and the growth of the cities. And finally, to end, talk about education. So when we're talking about research and this area of new space, the instrument we want to use for the education and for research are these nano satellites, or what we also call cube satellites. And these cube satellites are built of these cubes of 10 by 10 by 10 centimeter boxes, which we can put together up to 12 units, and you can put all your sensors inside here. And in fact, our students here in the Porter School are going to be part of the first satellite built by Tel Aviv University, which we hope to have in space in less than 2 years by 2020. And this has already been done by students in a high school in Herzliya. These are students, high school students, who've actually built 2 of these CubeSats, the Duchifat Echad V'Shtayim, Duchifat 1 and 2. And we're now part of a national project called Israel 70. For Israel's 70th birthday this year, we plan to help launching 70 of these satellites from 70 schools around the country. And in this box here, to end this talk, I have the prototype of the first satellite from Tel Aviv University. This is the exact size of the satellite which is in space today, and this is what we'll be building and launching in the next 2 years. Thank you.